Hello. I don't know about you, but this video is being recorded on a beautiful Saturday afternoon. Okay, 3.2 radians and degrees. Take notes. Make sure you are checking in for attendance on Canvas. And make sure you are keeping up with the assignments, which are on WebAssign. Okay, so radians and degrees. So hopefully you are comfortable with working with trig functions in degrees, because now we're going to switch uh, units of measure, and we're not going to do degrees, but we're going to be doing radians. Okay. So just a quick review. What is the sine of 30 degrees? 1/2. Okay, so if you said 1/2, very good. What is, and remember, as far as 30, 45, and 60, those are the ones you need to memorize, and the quadrantal angles, 0, 90, 180, 270. Okay, but 30, 45, and 60. And for the most part, for sine and cosine, your answers are going to be either 1/2, square root 3 over 2, or square root 2 over 2. Okay, so hopefully you have those memorized to make life in trigonometry a little bit easier. Okay, what is the cosine of 30? Quick, quick, what is it? Good, square root 3 over 2. Okay, what is, let's see, what is the sine of 60 degrees? Square root 3 over 2. Good, and cosine of 60 degrees? Excellent, 1/2. And what is sine of 45 degrees? Square root 2 over 2. Good. I know you're like rushing. You're like one of those Jeopardy people. Okay. All right. And then same thing with cosine of 45 degrees, square root 2 over 2. All right. So radian. What is radians? So just like distance can be measured in different units. Same thing with angles. So like with distance, you can measure like the distance from here to the corner in feet. I could measure it in yards. I could measure it in meters. I could measure it even in inches. Okay. And then same thing with angles. You're used to measuring angles in degrees, but we have other units of measure as well, and the radian is one of them. Okay. All right. So what is it? It is an angle measure, such that 1 radian. I'm going to write my 1 like that so it doesn't look like an I. Such that 1 radian measure occurs when the radius of the circle equals the arc length. And I'll draw a picture of this so that you can see what's happening here. And it's actually kind of interesting. So, so let's say you have this circle, right? Let me just draw a dotted circle. Do the best you can. All right. And suppose that this here is the radius of the circle, right? And then suppose that you have an angle. So an angle, a very specific angle, So here it's also r. So you have this angle such that, and let me grab, actually, let me do this one. No, not that one, this one. Okay. So it's an angle such that this arc length right over here, that arc length is the same distance as the radius. Okay. So here, this arc length is equivalent to the radius. Okay. And when that happens, this angle here, I'm going to call this r as well. It's not a radius, but here, how about if we do this? We won't call it r because then r stands for radius. Let's call it x. So this has some radius x, and when you have 1 radian, so that angle there is 1 radian, then the arc length, this highlighted purple area, is exactly the same length as the radius. Okay. My drawing is a little off, but not that bad. Okay. All right, so that's what that means. That's when you know you have 1 radian. So we see here, it looks like it takes what? How many radians to fill a circle? It looks like it takes 1, 2, 3-ish, 4, 5, like kind of close to 6, maybe a little over 6, right? Okay, so in general, theta equals S over R, where S equals the arc length and R equals the radius. Okay, so here, let me draw another picture. That's a terrible circle. That's a little bit better. Okay, so if you have this angle here, theta, this is the radius r, and this is the arc length s, then that's what they mean by theta is equal to the arc length over the radius. Okay. So that if you get something like this, for example, find theta if radius, I only give you like one of these problems in the homework, radius equals 3 centimeters, and the arc length equals 6 centimeters. Find theta. So we're going to use this formula up here. So theta equals S over R. That's arc length over radius. And we have those two pieces of information. So S, arc length, is 6. And radius is 3. So theta is 2 radians. Okay. All right. Now, let's go back to how many radians are there? So I started to talk about it up here, about how, okay, well, if that's 1, this angle right here is 1 radian, then it looks like that's where 2 radians would be. And then this is where like 3 radians would be. And then 4 radians would be here, 5, and then 6-ish. Okay, so let's revisit that. And let's take a look at the angle in terms of the degree and radian relationship. Okay, so let's have a look here. So I'm going to draw that circle again. Okay, and let me try to draw 1 radian. So there's my radius. So that should be about, I think, maybe right there. That's where the arc length looks like it's equal to the radius. Okay. All right, so that's 1 radian. Let's pretend that's 1 radian. Okay. Okay. And so we see that 2 radians would be like there, right? 3 radians would be like there. Okay. Um, and then this isn't quite to scale. This one looks a little bigger here. So we are like not quite there, like maybe there. You don't see the difference, but I do. Okay, so it's actually not exactly 3 radians to make a half circle 180 degrees, right? So here, we know that that's 0 degrees, and we know this is 180 degrees, right? But our focus is on radians. So it's not quite 3 radians that make 180 degrees. It's almost 3 radians. Almost 3 radians equals 180 degrees. Okay, so it actually takes a little bit more than 3 radians. So the actual is 3.14 radians. So it takes a little bit more than 3 radians. It takes 3.14. Does that decimal number seem familiar? Do you feel like you came across that decimal before in your life? Maybe at a bar? Okay. This is pi. Pi radians. So that's how many radians are equivalent to 180 degrees. Okay, so here, 180 degrees equals pi radians. So now with that information, now we can divvy up the circle in terms of pi, and we can see the relationship between pi, the different radians, and the different degrees that we're familiar with. Okay, so let's start with the quadrantal ones. Okay, so here are our radians. Here are our degrees. Okay, so 0 degrees, well, that's going to be the same as 0 radians, right? Okay, and let's go here, 90, 180, 270, 360. So we're going to take a look at these quadrantal angles, okay? Let's go back up here to the picture. Okay, so we see here that, okay, so from the 180 degrees is pi radians. So then what's 90 degrees going to be? If from here to here is 1 pi, then halfway is pi over 2, because we have half of pi radians. Okay? And so we know 180 is pi radians. Hopefully yours are lining up better than mine. Okay, and then 270. So 270 is going to be, well, we know that's 1/2, 2/2, 3 halves, and then 4 halves. So 270 is 3 halves pi radians. And then 360 is 2 pi radians. Okay. All right. So hopefully you're able to see that. Again, if this is 1, then this is 2, right? If that's 1 pi, then that's 2 pi. If that's 1 pi, then this is half a pi. If this is 1 pi, then over here is 1.5 or 3 halves, right? So that's how we came up with these here. 0 degrees is 0 radians. 90 degrees is half of pi radians. We already know that 180 is 1 pi radian. Okay, not 1 radian, 1 pi radian, or 3.14 radians. Okay, so 0, pi over 2, half of pi, 3 pi over 2, and 2 pi. Okay, so 0, pi over 2, pi, 3 pi over 2, and 2 pi. Okay, so that's how we got these. These are our quadrantal angles. And hopefully you are able to say what the sine, cosine, and tangent are of all of these off the top of your head. Okay, let's look at our 3 other ones, 30 degrees, 45 degrees, and 60 degrees. Okay, so let's take a look at these 3, and let's take a look at how many radians these guys are equivalent to. Okay, these are our basic angles, right? And we know the sine, cosine, and tangent of these basic angles, right? Okay. Okay, let me draw the circles here so that we don't have to scroll up. Okay, so we already know that that's 0 radians, and this is pi radians, right? Okay, so let's take a look at 60 degrees, right? We know that's 60, 60, 60, 60, right? Each of those is 60. How many 60s does it take to make pi? It takes 3 of them, right? It takes 3 of these 60s to make 180, which is pi radians, right? So it takes 3 of these 60s. So we know that each of these is 60, right? Therefore, this one here, in relation to radians, we see we have 3 pieces here, right? So if we're only talking about this one here, right, this piece here, then we only have 1/3, right? One of the 3 pieces up here, one of the 3 slices, we only have 1/3 of pi, right? So 60 degrees is 1/3 pi radians. Okay? And then we can do the same with 30 degrees and 45 degrees. Let's do 45 next. 30, that's a lot of pieces. Okay, 45 degrees. So we know that this is 45. That's another 45, right? 45 and 45 is 90. So that's a 45 angle. That's a 45 degree angle. And so it's this one and this one, right? So 45 and 45 make 90. And then 90 and 90 make 180, right? Okay, so we see that it takes four sets of 45s, right? 4 sets of 45 degrees to make 180. Okay, so if we only look at one, if we only have that one, then we only have 1/4 of pi, right? 1/4 of pi. So 45 degrees is 1/4 of pi, right? Okay, and then 30 degrees, it takes 630 degrees to make 180. So let's see, 30, 30, 30, 30, 60, 90, another 30, and then another 30. So each of these is 30, okay? And here, let me do this so I can write in it. 30, 30, 30, 30, 30, and 30. All right. So here, if we have 30 degrees, it takes 6 of them. 1, 2, 3, 4, 5, 6. It takes 6 30 degrees to make 180, right? 180 and pi are the same. Okay, so it takes 6 of them to make 1 pi radian. Okay, not 1 radian, 1 pi radian. Maybe I should just say pi radian. Okay. So if we only look at one of these, then we see here that 30 degrees is equal to only one of the 6 pieces, right? 30 degrees is only one of the 6 pieces. So 30 degrees is equal to 1/6 of pi, okay? Okay, so hopefully that makes sense, okay? Hopefully that makes some sense. So let's take a look at converting just in general. Like, so suppose that we don't have 30 degrees. Okay, so great, we have these memorized, 30, 45, and 60. Those are equivalent to pi over 6, pi over 4, and pi over 3. But what if I have something like 72 degrees, right? How do I convert that? Okay, so let's take a look, converting. Okay, so if you're doing, it's actually not as complicated as as it seems. Like when I remember when I took trig, and I thought I don't know why, but I thought this was difficult, but it's not. Okay, so when you're converting degrees to radians, okay, if you know what you're trying to convert to, like if you're trying to convert to radians, then that will tell you what you're going to be multiplying by. Okay, so if you're converting degrees to radians, then you are going to multiply. So first of all, you can only multiply by 1, okay, or else you change the value, right? So if you have 30 degrees, if you end up multiplying by some number other than 1, right? If you multiply by a number other than 1, then you no longer have 30 degrees, right? We're trying to find something that's equivalent to 30 degrees, okay? So keeping that in mind, that means that you can only multiply by the number 1, right? But you have to multiply by 1 written in some equivalent form, right? Um, so here we already know that we already know that 180 degrees is equal to pi radians, right? We already know this. right? So since 180 degrees equals pi radians, then 180 degrees over pi radians equals 1. So that's how we get our 1 written in some other form. Okay, so here, let me do this. 180 degrees over pi radians. This equals 1. Okay, and then here, pi radians, if you write it like this also equals 1. Okay, because 180 degrees and pi are the same. Okay, so here, if we want radians, we're going to go ahead and multiply with the one that has radians on top. Pi radians over 180 degrees. Okay, and if we are converting from radians to degrees, then we are going to multiply the radians by 1 written in the form of 180 degrees over 180 degrees over pi radians. Okay, and this makes sense because if you want radians, then you should end up with radians. If you want degrees, then you should end up with degrees. And what happens is the degrees here, this one right over here, this will cross cancel. And then over here, the radians will cross cancel. You'll see. Okay, so let's take a look at an example here. Let's go ahead and convert 50 degrees to radians. Okay, so I have my 50 degrees. So this is a little dimensional analysis. If you're taking chemistry, right, you do some dimensional analysis, and you're always multiplying by 1 written in the form of some equivalence, right? 180 degrees over pi. Okay, so we want radians, so we're going to do the one where it's radians on top and degrees in the denominator. And so what happens is the degrees cancel. Okay? And that's how you end up with radians. Convert 50 degrees to radians. Okay? There's more than just the degrees that cancel here, so that's kind of nice. They both have 10 in common, so that cancels. So then here we see we get 5 pi radians over 18. Okay. Normally they don't use the radians. They just know that, okay, if you write it like this and there's no degree sign, if there's no degree sign, then it's understood to be radians. Okay. But I like to write it for now so that you know that we're talking about radians. Okay. Okay, so let's go ahead and convert 430 degrees to radians. Okay. So again, we have 430 degrees. Do our little dimensional analysis. So we want to cancel out the degrees, and we want to end up with radians. Okay, so here the degrees cancel out. They're both divisible by 10. And we get, what is that, 43 over 18? 43 pi over 18. You can leave your answer like that. I'm going to add the radians. I'm gonna add the word rad so that you guys can all have a rad day. Okay. Does anyone say rad anymore? Okay. Trigonometry is rad. Okay. Convert negative 47.5 degrees to radians. And let's go ahead and round to the nearest hundredth. Round to the nearest hundredth. All right, so negative 47.5 degrees. So when it says round to the nearest hundredth, you're actually going to work out that pi into your answer. Okay, so your final answer. Um, so we want to cancel out the degrees, and we want to end up with radians. Okay, so if you're going to be rounding to the nearest hundredth, then that means punch that whole thing into your calculator, and you should get negative 0.829. Okay, again, you can leave your answer like that. Okay, but I feel like if you guys see the word rad enough times, you'll start feeling pretty good. Okay. Okay, let's try some the other direction. Let's go from radians to degrees. So convert pi over 6 to degrees. Okay, so that's how they will probably write it in the homework problem. They don't have the radians there, but again, I think it's helpful to have the radians here so that when you're doing your conversion, this little thing here, dimensional analysis here, it makes sense which units are going where. So here, well, we're going to have 180 degrees, and now the pi radians are going to go here because now they can cross cancel. Okay. We can see that the 6 and the 180 will also cross cancel. Okay. Ooh, and the pi and the pi will cross cancel. Okay. This is going to get a little messy. I'm going to make my thing here a little thinner. And I'm going to, I'll use a different color for each one that I'm canceling. Okay. So the pi and the pi will cancel. And then the 6 and the 180. 6 goes into 180 30 times. Okay. And so here we see that we end up with 30 degrees. 30 degrees. Okay. And that makes sense because we had already looked at pi over 6 and we said way up here, where is it? We already said up here pi over 6 is equal to 30 degrees. Okay. Because 30 degrees is 1/6 of pi. All right, let's take a look at this next one. Let's convert 7 pi over 3 to degrees. Okay. All right, so 7 pi over 3. They don't have radians, but I'm going to go ahead and put it there. And so we want to cancel out with radians. So radians will go down here while the 180 will go up above. Okay. Again, the pi's cancel out. Let me do my, okay, so pi cancels out. And then 3 and 180 will cross cancel. 3 goes here once. 3 goes here 60 times. Okay. And then if I multiply that out, I get 420. Okay, so how about you try this one and we'll end here. Try this, convert. Let's see if you can round to the correct um, number. Okay, so convert negative 3.4 to degrees. Again, they don't write down radians, it's understood. But if you want to write radians after the negative 3.4, feel free. All right, round to the nearest tenth. All right, so go ahead and hit the pause button and come right back. All right, so negative 3.4 radians times, okay, so we want to cross cancel the radians. So that will go there, and 180 degrees will go here. So radians cancel. Punch this into your calculator, and you should get negative 194.8 degrees. All right, so that is it for part one. In the next part, we're going to actually do trig functions. We're going to take the sine, cosine, tangent, etc. of these funny radians. They're not funny. Okay, I will see you in part two.